In this lesson, we'll be talking about cryptographic hashing. And while the word cryptographic is in the term cryptographic hashing, and it does lead you to the belief that there is encryption involved, there is no encryption involved in a cryptographic hash. There is a significant difference between hashing and any sort of encryption, and that is primarily that encryption is a two-way process. When I encrypt a piece of data or a file or anything else, what I'm doing is putting it into a state where I expect to be able to get it back out again. In other words, when I encrypt a file, I expect to be able to decrypt the file and get the original contents back. Hashing is a one-way function. Once I've hashed a piece of data or a file, there is no expectation and no ability to get the original piece of data back. Hashing generates a fixed length value, and different types of hashing will generate different length values. For example, MD5 will generate a different length value than SHA-1 hashing. They're both hashing algorithms, but they generate different length values. The resulting value from a hash function should bear no relation at all to the original piece of data. As a matter of fact, if two inputs generate the same hash value, it's called a collision. And if you can generate collisions, you may be able to get to a point where you can generate pieces of data that are going to generate the same hash value, and that leads you to the potential ability to break the particular hashing algorithm that you're using. So what can we use hashes for? Well, one thing we can use hashes for is file integrity. We can run a hash on a file and get a value back, and later on we can check that value to make sure that it's the same. If it's the same, I can be sure that it was the same file that was hashed in both instances. So sometimes when you're going to download like a software package from a website, you will see cases where there's a hash value. If you download the software, you run a hash algorithm against it and compare the value to that was posted on the website. If the values are the same, you know that what you got is the original software without any sort of corruption. So we can show you a simple hash process here. Run MD5 sum. This is on Linux, but you can get a version of MD5 or an MD5 summation program for Windows, and Mac OS comes with a utility called MD5, which does the same thing. So I have a file here called ca.crt. I'm going to run an MD5 sum against it, and I get a value back. Since it's the same file, I'm going to get the same value back every time. Another use for hashing that you will often see is we hash passwords. The reason for hashing passwords is so you're not storing the clear text password, which would be easily seen, even if you've got it protected with permissions. If I hash the password, every time I hash that password, I'm going to get the same value back from the same algorithm. So what I do is I store the hash in some sort of password database. Since it's a one-way function, you can't get the password back directly from the hash. Now what you can do, most password cracking programs do some variation of this, is you generate hashes against a list of words until you get a hash value that matches the one in the password file. Once you've got the hash that matches the one in the password file, you know what the password is. And here's where we come back to the idea of collisions. If I can take two different strings of characters and get the same value back, then it's easier to crack passwords, because I may not necessarily get the password, but if the hash that I get back from a particular string of data is the same as that I get from the original password, then it doesn't matter whether I know the password or not, because the string of data that I put in is going to generate the same hash value, and what you're comparing when you log in is the hash value. So let's say the strings dog and cat got the same hash value. Your password was dog. I plug cat into a hash that generates this hash value that compares to the same as the one for the word dog. While I'm using cat, since the hash value from that is the same as the one for dog, I would be able to log in even though I don't know your password. So it's not necessarily critical to know the password. All you're looking for is some string that generates the same hash value, since that's what's being compared anyway. And that's a little bit on hashing.